lots of vocabulary. Okay, lots of vocabulary today. You have the word extrema or extreme values. You have absolute or global. You have local and relative extreme values. So we're going to talk about that first. It's not exactly exciting, but we have to know what that is. You will remember it from pre-calc. This class did. Max and mins. Now in pre-calculus, you just graphed it and you read your points off of your graph. In this class, we have to use the calculus. On the exam, to find a max or min, even if the problem is in the graphing calculator section and they give you the function, you still have to do the calculus that we're going to do today. You can use your graphing calculator to verify you're right or help you see it, but it's not sufficient. It's all done on the computer. Close enough. We're going to learn what critical points are, and we're going to do the extreme values theorem, which another name for it is the max-min existence theorem. And I go back and forth with the names because it was different in my other book, so I don't remember which one's in which one. But it doesn't matter. Okay? There's a lot of stuff. And if you think it's about what we're doing, it's not that bad. Yes? Maybe? Oh, maybe? I don't think anybody's seen it.
No, the one that, yeah, everybody saw that we took the Parker test.
We're doing a big test. Individual test. Not everybody. Not everybody. Okay. I'll try to get there, but it just depends. I'm not going to rush through this. We have plenty of time tomorrow. Okay, there's my function. Extreme values. And they're going to use these words on the exam. They might call it extremum. Well, they're just extreme values. So what they're looking for is the maximum, I'll put / minimum, value of the function. We get confused. Are they talking about the x coordinate or the y? The x is where these occur. I want the value of the function. That's the y value. And I'm going to repeat that many times. As we sit and grade these problems, we say, why don't the students answer the question? It's asking for the value of the function, not where it occurs. They might ask you where it occurs. So you're going to make sure that you read the problems carefully and answer the question. So that's all extreme values are, the max and mins. So on this particular graph, is there a maximum value of this function? Now we're going to assume that these are closed, okay? They look close to me. We will assume that. And the maximum value is? Okay, so the maximum value is approximately 2.5. You did this last year, right? Now, they're just going to use the word maximum if they want the biggest one. They won't say find the biggest one. They'll just say find the max. It's the biggest. Where's the minimum? What is the minimum value?
Negative 2.7.
This is the minimum value. It's the y coordinate, approximately negative 2 points. I'll take that. It's good. Okay. Now, these are the absolute ones. We do have other ones, though. We have local ones. A local one, did you look locals last year? I look at it, man, it's a max. Okay, Grant, it's this one right here. It occurs there, and it's locally, it's the biggest one in the neighborhood. So we could talk about holiday lights, because a lot of people put up holiday lights. And in a certain neighborhood, somebody has the best lights. But they're not necessarily the best lights in the city. You have to go to different neighborhoods and you want to find the absolute best one, maybe in the state of Minnesota. But within the neighborhood, looking at just the neighbors, that's the best one. So that's a local max. This is also a local extreme, local minimum. Now, this absolute one, it's also a local one. This point is still bigger than its neighbors. So it's an absolute and it's a local max. Now on the exam, they will say local, or the other word is relative, if that's what they want. If they don't use that word, you know I want the biggest one. So we're going to learn a theorem today that will guarantee it. Okay? There is both a max and a min. Where does it occur? Did we talk about where it occurred? This occurs where? At x equals 2. And the minimum occurred at x equals 3. Something special about these max and mins. That's the truth. What's special about, now let's drag a little calculus in here. That's right. The derivative is, now I can't do this at that endpoint because I don't know what's happening on the other side. I never talk about endpoints as being local max or mins. They can be absolute. This book does include the endpoints. What can I say?
Why is it 3?
At x equals 3.
No, it's either 4 or 2.
Oh, it's a 2. I'm sorry, I can't read my own graph. I can't read. Sorry, that was 2. Whoops, I'm still in this one. The minimum here is wherever that is. I can't even.
No, it's 4.
1, 2, 3, 4, 5, 5.5. It's just my graph. Okay. Now, how would you find the max? If you wanted to find max and mins, what would you be looking for?
Mid.
Where f prime is what? 0. There are other kinds of functions. What about this one? That's the absolute value function. So what f prime is undefined, or you can say does not exist. Where these occur, where the derivative is undefined and the derivative is 0, those are called critical points. Critical. But the derivative is 0 or does not exist. I told you, there's lots of vocabulary, which makes the reading, actually the reading's pretty good in this book, but makes the reading hard. So if you want it all, if you want all the details, it's there. Okay, there was another question on your handout, but not on mine. What are the conditions for the function to have a max or min? That the derivative is 0 or the derivative is undefined. I'll do the guarantee in a second. Okay, ready to turn the page? This is more of a formality. It's just how you write this out in terms of mathematics. You're probably not going to really do much with this. But what's true about the y-coordinate here if this is a maximum value? Grant? What's true about the y-coordinate there compared to the other ones? How can you say it mathematically? F of c is bigger than all the other ones, so we'll just call the other ones f of x. Okay? You're filling your chart, your stuff. What about the minimum? What's true about my f of c here?
Is less.
Yeah.
And you can't say less than.
Well, within the neighborhood. It's not less than. How want me to do this? Within their neighborhoods.
Well, no, this one, I don't think that.
That's true. But it's also true. Yeah, you can write. I mean, they actually call them neighborhoods in mathematics. Yeah. That wasn't me making that up. Okay. And what is the extreme value? Again, what's the extreme value?
I always had trouble.
The max. Extreme values are the max and the mins. Okay. Now, part 2. I want a guarantee here.
Extreme value is extreme value. No maximum.
Not necessarily it's the derivative 0. It's just the maximum minimum value of the function. Let me put that in there too.
So our local.
These are candidates. These are places where it could occur. Let me give you an example where the derivative is 0, but is not a max or min.
So I have a question. Is the ones that are local mins but not the like biggest, minimum, and maximum? Is that still an extreme value, or there are extreme values?
Local ones are also considered extreme values. What's true about this one? The slope is 0, f prime is 0 here, but is this a max or min? It's neither. Okay, so these are the places where we look to find them. We'll talk about how we find them. Okay? So my question in part 2 is, when must a max or min exist? What I want here is a guarantee. What are the conditions? Because I always like guarantees, right? I love guarantees. To guarantee there is both a maximum and minimum value of the function. You get both. When must the max or min exist? This is not iffy at all. This is a guarantee. I promise you. This is a promise I got to make to you. That if we have these conditions, we will always have a max and min. And then, when you're on the exam and they're talking about max mins, you're going to be looking for these conditions, and then I'm hoping you'll say, oh, I have to use this theorem, then it's easy. Okay, so let's just look at some things here. I'm just going to draw some pictures. So if I have this function here, okay, can I find a maximum value on that function? An absolute. We're talking absolute. Can I find an absolute max? You might say, well, I can get really close to that point there, but you know what? I can always find another one bigger. I can always do that. I have a min. There's a min. No problem there. What's the problem with this function? Why can't I not have a maximum?
Because it's not. It does not.
It's not what?
A whole.
It's not continuous as a whole. So if you don't have, now, in this particular function, you can have a discontinuous function and still have a max. Now, remember, I'm looking for a guarantee. It will happen every time. If you have a discontinuous function, you could have, can you have an absolute max and min? Oh, what about this one? There's a minimum, but there's no max, is there? But what about this one?
That's continuous. Yeah.
Not continuous.
I mean, that's.
But it does have a maximum and a minimum. But there's no guarantee. Remember, this is a promise. So if you have a discontinuous function, I can't promise anything. Then you're in trouble.
Your promise is that there's a continuous.
So I have to have a continuous function. That's one of them. So what if I take this? What if I take this? Is there a max and min on this line? Yes. What about this line? So what else has to happen? You've got to have endpoints. Must be a closed interval. This is not. This is no max or min. I'm going to write that and then I'm going to summarize it. Okay? There's a lot of talking. Come on, Beth. Okay. So to guarantee, and you get both the max and min. F of x must be continuous and on a closed interval. That's a guarantee. That's a promise. So when you are on the exam, and they talk about finding a sorry, it's crooked, max or minimum, and you see a closed interval, you're going to say, yes, there's a guarantee, I know they're there. Okay. That's important. This is the max-min existence theorem. I want to give you more stuff on this, like how do we use it, rather than just getting the theorem. If you think about it, it should make sense. So I'm highlighting it because it's so important. I can't remember a free response exam that hasn't had this on there. So in the spring, I have organized all the FRQs. I've made a spreadsheet of all the FRQs and the main topics. No, let's do some props. And the main topics, and you'll see the themes carried through. Some things were not tested on the FRQs, but this one has almost always been there. But you'll get a copy of that. And so these are things we're going to look at. And I'll say it was 2005 problem 2 that you're going to see the max-min existence there. Okay, so let's do this. Where do extreme values, what's an extreme value? Max and min, right? Where do they occur? I'm repeating myself. Where the derivative is 0. Where the derivative is undefined, and at x equals a and b at the endpoints. I'm being redundant. Make sure we get this. That's all. And you don't necessarily need to know this. I have never seen these words on the exam. Stationary singular. Those are the endpoints. I'll put it in English.
So it's critical where the endpoints are.
The critical points are the endpoints and the derivatives being 0 undefined. Mostly when they talk about critical points, they're really talking about this. But I want you to consider the endpoint. You have to consider the endpoints, because the maximums often occur there. Okay, so stationary points. This is just so vocab. I'm not going to test you on this at all. I might use that word, but often I don't. It's where the derivative is 0. Singular points. It's where the derivative is undefined. Because you're going to see these words in your textbook. But I've never seen them use this on the exam. Extreme values? Yes, I have. And endpoints are where x is equal to a or b. It's the endpoints of the interval. It's kind of obvious. Yeah, or does not exist, whichever way you like to write it. Okay, so this is the max-min existence theorem right here again. Or extreme value theorem, I think that's what they call it. This is the guarantee. What are the two things you have to look for? F of x is continuous. And what else has to be true? Has to be on a closed interval. I'm going to go one step further, talk about how to use it. Okay, Grant, you have that? Oh, there is. Okay. Now, I'm going to take this other stuff off. I'm going to talk about how do you use the theorem. And it's pretty straightforward. First, you check to see if you match these conditions. Okay, so one, how do we find? Now we're talking about absolute max-mins. Max-mins. Well, first thing, f of x has got to be continuous on a closed interval. You check. Because if that condition doesn't work, and in some of the homework problems, it doesn't. There are a lot that are from negative infinity to infinity. There are a lot that are in an open interval. And when you get in an open interval, you have no choice but to graph it and look at the picture. So, and they have them mixed up, unfortunately, in here. The second thing you do is you find your critical points. Now I'm going to abbreviate it CP. Is that okay? Critical points. I'll write it down here too, though. Where are the critical points? F prime is 0. F prime does not exist. And what else? It has to be on a closed interval. Your other place are the endpoints, right? Those are your critical points. How do you, now once you find them, so what? How do you know if you have the maximum or minimum value of the function? What would you have to do to know if it's the maximum value? No calculus at all. You could graph it, and by graphing it, you would find the,
What are critical points again?
right here.
One F.
F prime is 0. We're going to do a problem. F prime doesn't exist, and the endpoints, A and B. I'm going to write it this way so it looks better. Well, how do I know which one's the maximum and which one's the minimum? Why don't we just evaluate our function at those, and whatever's biggest is the biggest. That's the third step. Evaluate. I'm not evaluating the derivative. I've already used the derivative. Evaluate f of x at each critical point. I make a little table. You don't have to, but I do. At each critical point. Each critical point where the derivative is 0, where it's undefined, and at the endpoints. So I make little tables here. Okay, that's how you do it. Ready for a problem. Now you don't have this problem, so if you turn your paper over, you can do it on the back. Save space for the one that's there. We just chose to do that one later because it's hard. We're going to do an easy one. Vertical lines are not functions. If I have a horizontal line,
No, like wherever the function is, like horizontal or like.
well, can you have a max and min at a vertical tangent?
No.
No, because if you do this, I mean, I can't. I could do it at a cusp where that might be vertical. That's still not a vertical tangent. So that's not going to work, and you can't use it at a discontinuity because that's part of the theorem. It says you can't do that. So you're just looking at whether the derivative is 0 or the derivative is undefined. Okay, let's do this problem. I'm going to do the whole thing. I'll find the maximum and the minimum value. We'll just do the whole thing. And I think it helps to look at the picture. No? What does that look like? It's a parabola. It's a negative x squared, so it's what? It's upside down. Okay, so I'm going to get my calculator out before I even do this problem, and let's just look at it. So I strongly recommend, and I know I don't do this often, strongly recommend that you use your calculator. Now I have one of these functions already in here. I'm going to save it now. You guys know how to turn them off? Like I go over here, and if I press enter, that will not be graphed. That's my second example. I want to see just this one. And I don't want to retype that. It took me a while. I don't want to waste time typing it. So 4x minus x squared plus 6. Now I zoom decimal. And here's a problem. Oh, I got the little circles now. We know what it looks like. So be careful on the exam if you have to graph something in the graphing calculator section. They've done that before. And let's say that's what I put down on my paper. I'm not going to get points for that because that's not right. And we know what it looks like, so I don't have the right what. Zoom fit works most of the time, but not all the time. And as long as you have the domain, which I do, we can zoom fit this. It's 0 to 4. Otherwise, I could go in, if you want an alternate, you can look at my video from the other class. I go into the table and I see how big it is. But let's do the zoom fit. Window, let's make that 0. And we'll make that 4. And we graph. Now I see nothing. Okay, there, it's done. Zoom, and we're going to do zoom fit. I don't particularly like it because I don't know where it is.
It could be 0. It's definitely 0.
Well, the problem is there's more stuff on this stuff now. Okay, so now we should work. But I don't have the bottom of my graph.
Boy.
There it goes.
That was
Okay. But, you know, I still want the bottom part of my graph. I don't think I have that my y minimum is 6. Why don't we make that -1 so I can see what's happening? And I'll make that -1. Wrong sign. Because I can see it a little bit better. Because I don't know where the minimum is. I know where I know the max is, or where it is. But there it is. I have that circle thing, it's slow. Okay. Let's hide another picture. So obviously, this is the maximum. It occurs, it looks like it's going to occur at 2, but that would not count. And then here, it looks like the minimums. I don't know which one's smaller. Or maybe they're the same. So let's go do the work. So I kind of like to do my chart first, except sometimes I don't know how many values, so I'll just make it a bigger chart. I'm going to make a table here. There it is. And all I'm going to do is evaluate f of x at all the critical points. Well, there are 2 easy critical points. What are they? 0 and 4. I've got my endpoints. I always have those. If you don't have them, then you can't use the theorem. So there's only calculus is finding out where that is. So Grant, what's the derivative of this? What's the derivative of this? 4 minus 2x. Don't put equals 0 in right here because that's an incorrect statement. The derivative is only 0 at a point. So put it in the next line because they might mark off for that. And you can show the solve or you can just tell me what x is. What's x? 2. Positive 2. You also have the graph. Is this ever undefined? This is a polynomial. Is that derivative polynomial? Think of stuff. Is this derivative ever going to be undefined? No, it's fine. If I had over x, that'd be different. So I had an extra space. Are you okay with that? There's nothing there with this problem. Now, how do I know what the maximum value is? Put these critical points in to where? F of x. I want the maximum value of the function, not of the derivative. Okay, so we have to find f of 0. That's equal to 4 times 0 minus 0 squared plus 6. That's what? That's 6. Then I have to find f of 4. So it's 4 times 4 minus 4 squared plus 6. Oh, that's okay. You can have a max or min occur more than once, but the value, the y value, only occurs once. And then f of 2, we either could look at could look at our calculator if we wanted to, but we could just do this because it's pretty easy. And somebody said 10. I think that was Ricardo. Okay. What is the maximum value of the function? 10. This is the question. You guys see that? The question is not where. They could say where. They might say, well, where does the maximum occur? You have to read the question carefully. It's an absolute. This guarantees an absolute, both an absolute max and minimum. So I'm going to write this out. This is the absolute max. Okay, if I want to be safe, occurs, because when you're on the exam, you're in a stressful situation, so make sure you read the question. But if I want to be safe about it, I'm going to give them both answers. But you can't give them the ordered pair. That's not good enough. The chart is not good enough. You actually have to say the maximum value is 10. But if I'm non-confused, I don't know which one they want, so I'm going to give them both. It occurs at x equals 2, and the maximum value is 10. There. Now I've covered all my bases. I don't understand the question if they want where or what it is, so I'm going to give them both. But you have to be clear about which is which and what it represents. That's the problem. So since we're here and it didn't ask the question, what's the minimum? The minimum value is what? Is 6. It occurs how many times? Twice. It occurs at x equals 0 and 4. Sometimes the maximum values are at the end point, sometimes they're not. There's no guarantee where they're going to be. I just guarantee they're there. That's all there is. I got another problem. We'll try another one. So what I do is I first make sure this is continuous. I have a closed interval. Then I can use the theorem. In the homework, some are open intervals or half open. It doesn't matter, guys. Shh. When you get to the open intervals, you'll evaluate your functions at these derivative points. But really, the only way to know if it's an absolute max or min is to graph it. Unless you know what I mean, you have to look at the picture. You have to consider the picture. If you know what it looks like, you know it's a parabola, fine. We're going to do another one. Are you ready? Oh, yeah, you don't have it, so you can't even try it. Find that one. F of x equals x cubed plus x squared minus 8x plus 5 on that interval. Is this continuous? Yeah, it's a polynomial. Polynomials are wonderful. Is my interval closed? Yes. So then all I have to do is find my critical points. I've got 2 right now. And then I need to find where the derivative is. So I'm looking where f prime is 0. Is this going to have any undefined points? No. I'll put it in parentheses, f prime undefined. It's not there. Actually, I like those because those are usually easier algebraically. And then, once I do that, I just have to evaluate it. So I'll get my little table. Too bad you guys can't do this. I don't know how many there are, so I'll put too many down there. And so then I want to do, this is x, and this is f of x. Well, I can do f of, I can't do -3 and 2 very easily, can I? So these are my endpoints. And I have to do some work to get where y prime equals 0, right? So let's find the derivative. That's right. Y prime is equal to 3x squared plus 2x minus 8. And I want where that's 0. Now, some of you like to put the 8 on the other side and do 0 product property. You can't do that. The product has to be 0. It can't be 8. Right? So I'm going to slide this because I want this down here so I can work with it. It's just not fair, is it? So we're going to factor. You guys remember how to factor this? Well, 3x and x. There's no other choice. I put the signs in next. This is a difference sign, so I'm going to find the difference. I want them to be different signs, plus and minus. I then factor the 8. 1 times 8 and 2 times 4. If this middle number is reasonable, like 2, that's reasonable. It's not like 80. I'm going to try the ones close together. And it's trial and error. So, what would you like to put here? 2. Well, I changed colors on purpose because then you check. Is this positive 2x? And this one's minus 12x. That doesn't work, does it? Like I said, well, I'll just erase. So then, instead of that, you erase and you do what? 4 and 2. Does that work? Well, that's 4x. That's minus 6x. I get minus 2x. Not bad. It's not right. Switch the signs. You guys got that down. That's good. Okay, so I just have to make this one minus and the other one plus. Okay, and then we write out 3x minus 4 equals 0, or x plus 2 is equal to 0. Can you tell me what those values are? This is 4/3. Just be careful in the exam. It's so easy to write 3/4. And x equals -2. And it's easy to say positive 2. Always do a quick check. So this is 4/3, and this is -2. And honestly, I'm lazy. I want to look at well, I don't care if I look at the picture of it. I could. But I don't want to put that into the cubing. I don't want to do that, especially the 4/3, right? So guess what I'm going to do? I'm going to use my calculator because I'm lazy today. So in my calculator, in y equals, I have my function. I didn't want to type it in again. That's why I didn't want to do it. So I'm going to go to my home screen. Now, if you have an 84, it's a little easier, but you might not. If you don't have an 84, if you have an 84, you go alpha and you go trace, and you can get your y1. Okay, I'm going to do it the hard way. because most of you probably don't have a calculator that does that. So I go to variables, I go to the y variables, and it's a function. I want y1, and I'm going to use function notation. I want y1 of -3. I don't know if you knew you could do that. Did you know that? I could graph it and find the values that way. It's f of x notation. Because I'm doing my endpoints. So that's 11, right? You'd have to plug it in, you know, -27. Well, I'm lazy. Plus, I can show you little calculator stuff. Now, I don't want to do all that process of getting y1. I can do second entry. Have you ever done that? And I want to make this a 2. I'm going to delete that. Somehow I got to do that. And then I'm going to put the parentheses in. That's 1. It's okay because we're going to use our calculator. No, it is not. Now, there's another way. There's another way to get the y1. If you have this the new 84 calculator, you just arrow up. Press enter. Actually, I think second entry is faster. Okay, let's do 4/3. He doesn't even care if I put the parentheses there, but I like to be proper. So it's -1 point. Now, how many decimals do I need? 3. Now, a lot of people want to round that. I don't. I just truncate it. It's up to you. 518. Okay, so it's -1.518. It's the only negative number. Well, we haven't done that one yet. And now we want to find -2. So I'm just going to go second enter. And actually, that's okay. Was that -2? Okay, so I'm going to go back in here. Like I said, second enter is, unless you want to go back and look at your work, the scrolling is not that big a deal. -2. Delete that. And I get 17. Okay. Those are the functions. We could look at the graph. Which one's the maximum? That's the max. So the answer is the maximum value is not -2, is 17. I think if you wrote out a complete sentence like that, you'll have a better chance of giving them the right number. What's the minimum value since I'm here? They would not even look at this. Well, there's no guarantee on that. They might mark it off if you do it wrong. But what's the minimum value? -1.518. Try not to give more information than you are asked. Because if you give more information than you're asked and it's wrong, then they might take points away. It just depends. I've seen it sometimes when they do and sometimes when they don't. Is that okay? That's all there is. Now, on the homework, if it's a closed interval, this is all you have to do. But if it's not a closed interval, you're going to have to get your graphing calculator out and look at it. You're just going to have to do it. So, bring your calculator home. Wait a minute. I'm making an assumption here.
So what happens if
No, I don't want that.
closed interval?
We can take a homework problem and do one, and look at the test tomorrow.
No, let's look at the test. Let's look at the test now.
Should we take a homework problem?
No, let's look at the test now.
You got it? No?
Test now.
I don't have a book.
Ahora.
Just like write a problem.
I took an easy one. And from -infinity to infinity. Okay, guys?
Yeah.
The question was, what if it's open interval?
We don't know.
Well, you do, because I know what this looks like. This is asking for the 0. I'm going to look for the zeros. This is -2, x -3, because I want to graph this. And what happens when x is 0, y is 6? So it's at 2 and 3. It looks like this. Now that I know what it looks like, is there a maximum value? No. There's no max, but there's a minimum. We want to find that. Do you guys remember how to find the vertex of a parabola? Do you remember, did you ever learn that the vertex was at x equals minus b over 2a? You should have. I need to talk to the teachers because you need to know that quickly for SAT, ACT stuff. Okay, but let's do it. Guys, let's find out why that's what it is. Because what's true about the vertex? The slope is what? So what's y prime? 2ax plus b, and that has to equal 0. Subtract b. So 2ax equals minus b. What's x equal to? Minus b over 2a. We just gave that to you, but that's where it comes from. It's a calculator. So you can do this one easily. Y prime is equal to 2x minus 5. No, it's not that. She has to go. She has a point. There it is. Now, guys, guess what? I found where it occurred, but I didn't answer the question. What's the minimum? I have to find f of 5/2. Well, we're going to plug it back in the equations. 5/2 squared, because this one's not tough. Minus 5 times 5/2 plus 6. Now, my calculator will do the fractions, if I'm in fraction mode. So what's that? That's 25/4 minus 25/2 plus 6. Hey, guys. Shh. Common denominators. Let's just do these guys. So it's 25/4 minus 50/4. What's 6's fourth? Right? So now it's easy. That's the value. Do you hear the difference in the questions? One is where, one is what. And you just got to keep those straight. Most important one of the most important theorems, and I'll highlight them all for you. Not quite time to go. But we'll go over the test tomorrow.